Welcome. So I've given you a list of all the theorems and properties, or not all, but a lot of the ones we're going to use. So you already have all those definitions. In this lesson, in this podcast, though, I want you to personalize it a bit and add some of the extra information I have. You can use the sides, you can use some sticky notes, right? And I'm also going to give you some notes that you can do problems along with me. But this is the one that's in your notes, and you can add a little bit more information about the reflexive property. Right? So it's a property we use a lot to justify. So reflexive property states that any number or variable is equal to itself. It's also true that any side, and I want you to add a very important part that you might want to add to your notes, any side or any angle is equal to itself. So why is this important? It allows us to show that shared segments or angles in figures are congruent. So anytime we have something that's shared, we can show that it's congruent using the reflexive property. So for instance, here we have a diagram, triangle ABC and triangle ADC, they share something. What they share is a side. They share side AC. So I could say that AC is congruent to AC. Right? And it's important because now I know something in both triangles is congruent. Right? So I know I have a side in triangle ABC and a side in triangle ADC. That's congruent to itself, right? Or congruent to each other, right? And it happens to be that shared side. Right? So we use the reflexive property a lot when we have a figure that shares a side or angle with another figure. Right? So some important things that you should add to your notes. Allows us to show shared segments or angles in figures are congruent. And you may want to add any side or angle is equal to itself. You can also put my pretty little diagram here. So here on above here are some other examples. These we won't use in proofs, but it just kind of helps you make sense of it. So Gene is the same height as Gene. Right? A is equal to A, 5 is equal to 5, and any shared figure is equal to itself. The symmetric property. Right, so the symmetric property, and I'm not 100% sure this one is in your notes. Right, so that's why I have the word notes up there. So I want you to add this to your notes. You can add additional pieces of paper, right, and you can add sticky notes, whatever works for you. Right, so in your notes, I want you to add if A is equal to B, then B is equal to A. Why is that important? Well, it's telling us first, it doesn't matter which side of the equal side you're on. Second, it allows us to reverse the order of an equation and show that the result is the same. So I could say 35 is equal to 2x minus 8, but maybe I want the number on the other side. Maybe I'd like it to go left to right. I can switch it and make it say 2x minus 8 is equal to 35. We use that when we solve equations all the time. We'll use that in proofs if you want to make sure that the order we have something in matches what we're asked to prove. In your notes, I want you to add everything that's marked with a green asterisk or is underlined in green, all right, or written in green. Right? So add all that information to your notes, and you can always pause the tape so you can write this down. And here in our picture, Gene's the same height as Pedro, so now it's fine for me to say Pedro is the same height as Gene. And we can say that because of the symmetric property. Transitive property, very, very, very important. Right? So Gene is the same height as Pedro, and Pedro is the same height as Chris. Then Gene is the same height as Chris. Notice both Gene and Chris are the same height as Pedro. What that means, what the transitive property means is that if two things are equal to the same thing, they are equal to one another. So if A is equal to B and B is equal to C, notice they're both equal to B, they have to be equal to each other. Here I have a little example. So 5 plus 2 is equal to 7. And 3 plus 4 is equal to 7. Notice they're both equal to the same thing. Therefore, 5 plus 2 has to be equal to 3 plus 4 using the transitive property. I'm trying to squeeze transitive property here. So anytime we see that two things are equal to the same thing, they have to be equal to one another. And when you're working with a proof and you see that you've got something repeated, two different things, they're equal to the same thing, you should be thinking transitive property. Right, so transitive property of two segments or angles are congruent to congruent segments or angles, then they're congruent to each other. That's how we're going to use the transitive property. You don't have to write this in your notes. I have basically the same piece of information in your notes already, right? But anything else you want to add from here to help you would be a good idea. Right? And we're going to use all these properties in some mini proofs. Right? These are I call these mini proofs because they're really, really short, right? And we're learning some properties. Right? So angle 1 and angle 2 are vertical angles. Angle 2 and angle 3, and angle 2 is congruent to angle 3. We want to show that angle 1 is congruent to angle 3, which means we have to prove it to be true. Right? So now we're going to use what we know to complete our proof. Angle 1 is, and actually this is really important in all of our proof lessons, that you aren't just listening to me, but you are actively thinking about each of the definitions, each of the properties, and trying to predict what reason I'm going to use in a proof. If you do that, you're thinking about and trying to predict, I think Ms. Michelle is going to use this reason. I think that's why it's true. Right? You're going to be so much better at this, and your brain is actually going to grow. Your ability to reason is actually going to grow. Right? So now, angle 1 is congruent to angle 2. Think real hard. Why might I say that's true? What do you think? See if I can do this without moving it down too far. If you guessed I was going to say vertical angles theorem, you were correct. So angle 1 and angle 2 are congruent because they're vertical angles. Not only do we see that in the diagram, we're also told that right here. And we know from the last lesson and the last podcast that if we have vertical angles, they're always congruent to one another. Angle 2 is congruent to angle 3. Anytime you're told something, that's going to be a given. So let's write that down, right, so that you know what to write. So in your notes, I want you to write given, and we're going to use that. Oops, that was supposed to be an N. We're going to use that for, actually I'll put use, I'll leave the equal, I'll put an arrow instead. It's not really equals. So we're going to use for information we're told in words or pictures or diagram. Right? So we were told angle 2 is congruent to angle 3. So that's going to be a given. That's that reason. So you use given for anything that you're told. That was given to you. All right, so now let's look at the next part. Angle 1 is congruent to angle 3. Notice you've got two things congruent to the same thing. Right? What reason could we use to show that angle 1 is congruent to angle 3? Right? So predict what I'm going to say before I move the screen. Do you have your answer in your head? And if you thought I was going to say transitive property, you are correct. All right, so the reason it's transitive property of congruence is that we have a congruence symbol there. If we had an equals, it'd be called transitive property of equality. But if you just write transitive property, that will be fine as well. It'll be understood that it's of congruence when there's a congruence symbol, or of equality when there's an equal symbol, right? But the full name would include it. But it's not required that you write the full name. It's understood that it's of congruence when there's a congruence symbol. So it is fine to just write transitive property. Let's continue on. Oh, and I wanted to make sure it was clear that I wanted you to write this in your notes. So include this in your notes, right? Because given gets used in every proof. I've never seen a proof that didn't use given. In the diagram at the right, AB is perpendicular to BC. Or line, I should say line AB is perpendicular to line BC. What can you conclude about angle 1 and angle 2? Well, what do we know about perpendicular lines? How do perpendicular lines meet? We know that perpendicular lines meet at right angles. And when we have perpendicular lines, we know that 4, that's one of our definitions, right? 4 right angles are formed. We learned that in the very first group of lessons. So what would be a good conclusion about angles 1 and angle 2? All right, so if two lines are perpendicular, the angles formed are right angles. Conversely, if two lines intersect at right angles, they're perpendicular. Right, so that does work both ways. Right? And so, before I move that down, what we should conclude is that angle 1 and angle 2 are right angles. And we know that because perpendicular lines meet at right angles. So here we have a little application. We want to find the value of x. Right? We know that when we see the box there, that box means a right angle. We know that these two angles are vertical angles. Therefore, x is equal to 90 degrees because vertical angles are always congruent. So we can find the measure of something and then justify it with one of our definitions or postulates. Let's look over here. Right? Together, this angle, let's call this one angle 1. So actually over here, let me go back to this for a second. I'm going to give these guys a name too. So over here I could say angle 1 is congruent to angle 2. And that's because vertical angles are always congruent. Move this over. I can move it over, but I changed my mind. There's not space. Let's just leave it where it was. Oops. I should lock these things in place. I'm almost at the end of the podcast. I hate to record the whole thing for a board mishap. Oh, I entertained you there. All right, over here, I will just use the little space that's left. We have a linear pair. So let's call this one angle 1, and let's call this whole thing here angle 2. All right, we know it's a linear pair. All right? Because they're two adjacent angles formed by two intersecting lines. If we ignore the other line there, the other ray. So we know a linear pair. We know that angles are supplementary. Therefore, angle 1 plus angle 2 has to equal 180 degrees. We already know what angle 1 is, right? Because of the box there. It's shown to be a right angle. So angle 1 is 90 degrees. And angle 2 is made up of the 62 plus the x. And together, those angles add to 180. I could really use a teeny bit more space. I wish I had a place to move my diagram over. I wonder if I get rid of the words example and just move it over just a teeny bit. No, it says it's going to stay. Not going to move. Now you have a stupid box. All right, I'll continue writing. I'll squeeze my 180 in there. Did it fit? Can we read it? Will it show up? Sort of. That thing is an equal sign. I guess I tried to write it too many times. Can I move my writing over? And I just happened to look up and notice all these little dots. So I guess when I was trying to move things, I had the pen in my hand. And I created all these weird blue dots. Okay, so plus x equals 180. That's a tad better. We can add those together. 90 plus 62, that's 152. And if we subtract 152 from both sides, x has got to equal 28 degrees. Oops. My degree symbol is not the right size. There we go. All right, and so we found that measurement there. And we could check 62 plus 28. Yeah, that would be 90 degrees. And then another 90 gives us 180. All right, so we've applied something that we've learned to solve some problems. Things that we've learned about vertical angles, linear pair angles. So now we're going to do a proof. And actually I'm going to stop us at, we'll do this one together, and then I think I'll start the next one in the next podcast. All right, so we're given that angle 1 and angle 2 are vertical angles. We want to prove angle 1 is congruent to angle 2. Now, if we're trying to prove a theorem, right, so we know angle 1 and angle 2 should be congruent because they're vertical angles. If we're trying to prove a theorem, we can't use that theorem. Right? So let us take a look here at a proof and see if you can come up with the reason before I show the reason. All right, so angle 1 and angle 2 are vertical angles. Why might I say that? Is there anything on the page that gives this one away? I hope you have the right answer in your head. I hope you have an answer in your head and you're trying to come up with an answer. If you were thinking given, you're right. It says it right up there, given. Angle 1 and angle 2 are vertical angles. The measure of angle 1 plus the measure of angle 3 equals 180 degrees. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. All right, let's take a look where those angles are located. Here's angle 1. Here's angle 3. What do they make? All right, here's angle 2. Here's angle 3. What do they make? All right, hopefully you figured out what they make. Two adjacent angles formed by intersecting lines. Linear pair property. So those are linear pair angles, and we know linear pair angles are always supplementary. All right, so now why did I say the next thing? Angle 1 plus angle 3 is equal to angle 2 plus angle 3. Is there something you see that maybe gives this away? Two things equal to the same thing. What's that property that says if two things are congruent or equal to the same thing, they're equal to one another? Why, that's the transitive property. Now, sometimes there's another property that can be used in the same place. I think the transitive property is a better choice. However, and what we're going to learn about, substitution could also be used. And what substitution means is you're substituting one thing for another. In this case, I'm substituting angles 2 plus the measure of angle 2 plus the measure of angle 3 for 180 degrees. So sometimes you can use either substitution or transitive property. In this case, since they're both equal to 180, transitive property is a little bit better choice, but you would not be wrong if you said substitution property. And actually in this particular proof that I borrowed, that's what they chose to write. So both answers are correct. Right? So sometimes you can use more than one answer. And this is one, they overlap a little bit. And we'll talk more about the distinction between substitution and transitive property. There will be cases where you can't use the transitive property, where you're literally just substituting one thing for another. Like when you're evaluating an equation and they tell you let x be 3. Right? That's not transitive, that's substitution. In this case, I can say they're both equal to 180, or I could say since angle 2 plus angle 3 is equal to 180, I can replace 180 with it. Both of them work in this case. Now, can you figure out, it's not one we've gone over, the next reason. How did I get from angle 1 plus angle 3, and the m there just means measure, equals the measure of angle 2 plus angle 3, to measure of angle 1 equals the measure of angle 2. What happened that allowed me to go from step 3 to step 4? Now obviously you can see in step 3 there's 4 terms, in step 4 there's 2 terms. What is missing from both of the equations, or both sides of the equation? The measure of angle 3. When you're solving an equation, right, and you want to, you got the same thing on both sides, you might do something to get rid of that same thing. Right? For instance, if I had 2x plus 3 equals x plus 5, I have an x over here and an x over here. I might just say I can do this. And then I'd have, notice, something was gone from both sides. So what is that thing we did from both sides? I hope you have now figured it out, because I think I gave the answer away on purpose. Oops, I've gone a little bit too far though. Subtraction property. It's a subtraction property. All I did was subtract from both sides. Now, I have one extra step up here that we haven't learned about, and I have it up there for a reason. I typed that one in. I fixed this person's proof. If you notice, this does not match this. It's very similar, but they do not match. And in proofs, we wanted to match. So shame on this person who did this proof. They should have done one extra step and said angle 1 is congruent to angle 2 so that it matched. Because we can say that. The reason we can say that is a definition of congruence, and we'll talk about that in the next podcast. Definition of congruence just means that if two things have the same measure, they're congruent to one another. Or if two things are congruent, they have the same measure. That's what congruent means, right? If two things are congruent, it means you have the same measure. If two things have the same measure, you have to be congruent. Okay. All right, so we're going to stop with this proof. And then in the next podcast, we're going to do some more proofs. Actually, these are going to be some mini proofs. All right, bye for now.